Welcome again, class, to another discussion dealing with chemical nomenclature. And today we're going to spend our time discussing how to name acids. Acids are a little bit different than ionic or covalent compounds. They are basically ionic compounds, as we'll see in another chapter. And even though they involve often nonmetals, they bond in an ionic fashion, and we'll talk about that in another, what goes on with acids and bases and things like that in another chapter. But right now we're just going to deal with how do you name them. And the naming procedure is slightly different, but again, it's not too incredibly difficult as we go through. So let's look at some rules. And there's two different types of acids that we're going to deal with. One is binary acids. And again, as we've learned before, binary simply means that there's two elements in there. And in the case of acids, kind of the first thing to understand about acids is all acids have one or more hydrogens in them. And that's kind of really probably the easiest way to identify an acid is you will typically almost always see a hydrogen out in front of the compound. And so that kind of clues you in that that's an acid. With maybe the exception of water, and even water has some acidic properties to it in some senses, and we'll kind of deal with that when we get to the chapter on acids and bases. So if I'm wondering whether something is an acid or not, pretty much if it has a hydrogen out in front of the compound, then it's going to be an acid. And you're going to see that in all the compounds that we have here. So binary acids, the first of the two elements would always be hydrogen, at least one or more hydrogens. And then the second element will be one of the nonmetals. Often one of the halogens, not always, but that is not uncommon. So let's take a look here. What are the rules for naming them? The hydrogens are represented by the prefix hydro, so you don't actually name it hydrogen. And the reason we use hydro is because more often than not, the acids that we're talking about are in their liquid state. If they were in their gaseous state, then we would name them like we would name any other compound. You would name the first element gets its full name, and the last element you drop the ending and add IDE. But we're going to deal with acids in their liquid form because that's when they're most commonly used. And so how would you go about naming that? Well, the hydrogens are always represented by the prefix hydro. So that always goes before the name. And then whatever comes like the second element, you give it its name, and then you're going to drop the ending, and you're going to add the suffix "ic," and then the word acid as well. And so this is where we get some of our names, and we're going to see how this works here. So hydrogens are represented by the prefix hydro, again because we're talking about acids in their liquid state. And we're going to drop the ending of the second element and add "ic," and then the word acid, and then you've named your acid. So let's kind of have an example of this. Let's start with one that you're probably familiar with, HCl. And so we recognize, oh, it's got a hydrogen out front, and so this is going to be an acid. So how would I go about naming this? Well, it's a binary acid because there's only two elements. So the prefix that goes with this is going to be hydro, so that's going to be the start of my name. And then I'm going to look at my second element, and it's chlorine, and we said we're going to drop the ending, the "ine," and add "ic," so it becomes hydrochloric, and then we add the word acid. And so this is hydrochloric acid. So that's how we name that. Let's do another one here. So let's say we have hydrogen, and again you'll notice there's a hydrogen out front, so that helps me identify that this is an acid. And so right away I know it's an acid. Okay, how would I name an acid? Well, this is a binary acid, so there's only two elements. So the hydrogen, I'm going to do hydro because it's in liquid form, and then this is bromine, so I'm going to drop the ending and add "ic," IC, and so it becomes hydrobromic, and then I'm going to add the word acid to it. And the last one we'll do with binary acids is this one. This one, in case we have two hydrogens, but that doesn't change anything. And just notice I have hydrogens out front again, and because I have hydrogens out front, as a result, this is going to be an acid, and in this case it's bonded to sulfur. And so again, I'm going to start my prefix hydro because this is a liquid, and in this case it's sulfur, so I'm going to drop the ending there and add ic, so it's going to be hydrosulfuric and then acid. Hydrosulfuric acid is how I name that. So it's a pretty simple naming procedure. I'm just going to have hydro for kind of stands for the hydrogen, and also because it's a liquid form, and then I'm going to name the second element there and drop the ending, add ic, and then the word acid. So those would be what we call binary acids. Now, rules for ternary acids. And ternary acids basically are elements or acids that contain 3 or more elements. Typically it's hydrogen. You're always going to have hydrogen out front. And then typically it's going to be bonded to a polyatomic ion. So it's going to be an anion, and that anion is going to be a polyatomic ion attached to it. So, as we have here, ternary acids involve polyatomic ions bonded with 1 or more hydrogens, and you're going to see some examples of that in just a second here. So rule number 1 basically is this: if the anion's name, and again the anion is your polyatomic ion, it's your negative ion. If it ends in 8, so if you guys have been going through and looking at your polyatomic ions, you'll notice that the majority of them are either 8 or ite. There's a few that end in some other end, but those are the ones really that we are dealing with. And so if you have something like chlorate or carbonate or phosphate or phosphite or sulfite, those are kind of what we're looking at. So anything that ends in 8, that suffix, the ending changes. Instead of 8, it's going to change to ic, and you're going to add the word acid. So you're not even going to do hydro this time around. It's just going to be understood that it's an acid. So let's say we have chlorate, and it's bonded to hydrogen. So you would have HClO3. Then you would see the ClO3. Oh, that's chlorate. Okay, ends in 8. And so I'm just going to change the 8 to an ic. And so it just becomes chloric acid. That's it. And you don't have to do anything else to it. The second basic rule is if the anion's name ends in ite instead of 8, the ending changes to an OUS ending, and the word acid is added as well. I don't know that we're going to run into a whole lot of these here. The majority of the acids that we're going to deal with in our class are going to have anions that end in 8, and so they'll have an ic ending. So I do want you to know the rule, but I don't know that we're going to encounter a whole lot of acids that this is true of. So let's take a look at a few of these. Okay, this one here, you'll notice that there's more than 2 elements here. So it's not a binary acid. Matter of fact, you should notice that NO3 there is one of the polyatomic ions you're memorizing, and it happens to be nitrate. Okay, so the polyatomic ion here is nitrate. It ends in ATE, or 8, and so that tells me, okay, what am I going to do? I'm going to change the ending to ic. I'm not going to name the hydrogen. All I do is I just name the polyatomic ion, and instead of 8, I put ic, so it becomes nitric, and then I add the word acid. So here we see the full name. It's nitric acid. That's it. That's all I have to do. I'm just going to change that suffix on the end, the 8, to an ic, and it becomes nitric acid, and I'm done. Same kind of thing here. I'm going to take a look. Here I have H3PO4, which in this case, my polyatomic ion is phosphate. PO4 is phosphate. It's another one of the polyatomic ions that we're dealing with and memorizing. And because it ends in 8, then again, I recognize, okay, what do I do if it ends in 8? I'm going to change my ending to an ic and add the word acid. So instead of phosphate, it becomes phosphic, okay, or phosphoric. In this case, acid is what it becomes. And that's how you name acids with polyatomic ions. And really probably we'll simplify it even more in class, in that there will be several that will kind of point out that these are the key ones that you will need to know. And there's a chart on page 194 and 195 that has examples of a lot of these acids, both binary and ternary acids, and we will take a look at those. And I will point out some of the ones that are more common that you will have to know, and there's some that you will probably never encounter in this class, and maybe never again in your life. And so we won't focus a whole lot on those. We'll focus on the ones that you will see more often in this class. And that's it.